Every product we rely on today is the result of thousands of micro decisions, from the exact tension on a manufacturing belt to the precise chemical mix in a pharmaceutical plant. Modern industry runs entirely on data, but in its raw, natural state, that information is rarely useful. It is a flood of scattered numbers, logs, and sensor readings that create massive noise on the factory floor. Relying on gut instinct or misinterpreting that noise has severe physical consequences. Guesswork introduces structural flaws, deep inefficiencies, and costly biases directly into the products coming off the line. So how do engineers actually separate the signal from the noise? How do we measure accuracy, reduce those expensive errors, and drive continuous improvement when we are overwhelmed by information? We use industrial statistics. It is the essential vocabulary required to translate that chaotic factory data into smart, actionable problem-solving. This online degree-level course equips you to do exactly that. Across 7 chapters, we approach the curriculum as a sequential, step-by-step assembly line for taming information. Phase 1 establishes the foundational mechanics. We start by gathering and identifying those raw, unprocessed readings straight from the source. To process this, we rely on the R programming language. It pushes scattered variables through a central processing node to find structural patterns. R takes these uniform arrays and organizes them into precise rows and columns, creating a unified data matrix ready for analysis. By blending statistical theory directly with hands-on practice in R, the concepts you learn are immediately grounded in real-world application. Once the numbers are structured, decision-makers need to actually see the story those numbers are trying to tell. This chart shows exactly how we achieve that. We summarize thousands of complex data points by turning a flat matrix into a dynamic 3D topographical map, exposing immediate physical trends on the factory floor. But observing what happened in the past is only half the job. To understand the broader implications of these trends, we use statistical inference. It is impossible to individually test every single item coming off a production line. Statistical inference gives engineers the mathematical tools to take a very limited sample size and make highly confident decisions about the entire massive process. From there, we move to the next logical step in our analytical pipeline, regression analysis. This is where we stop looking at the present and start predicting the future. This scatter plot illustrates the regression process. By mapping the historical relationship between variables, we can draw mathematical conclusions, extending a trend line to accurately forecast exactly what will happen next. When you combine strong visualization with inference and regression, a business stops merely reacting to isolated production failures. Instead, they actively predict and prevent those failures before they occur. There is one final reality check required in this pipeline: measurement system analysis. A multi-million-dollar business decision is only as reliable as the measurements it is based on. Before making any systemic changes, engineers have to audit the testing equipment itself. This diagram shows how we evaluate system variance. We rigorously test the equipment for stability, bias, linearity, repeatability, and reproducibility to ensure that the gauge itself is giving us true, accurate numbers, pulling our measurements into a tight cluster. Passing this strict audit is the only way to guarantee absolute precision, ensuring that the entire pipeline is built on facts, not faulty sensors. That is the complete pipeline. We take chaotic, raw numbers, structure them, visualize them, and turn them into highly meaningful solutions for real-world challenges. Students apply these analytical frameworks to identify where production value is lost, using those insights to solve industry problems with an entrepreneurial mindset. By the end of this program, you will be equipped to confidently apply advanced statistical tools, analyze complex real-life datasets, and recommend data-driven strategic solutions to executive management. This is industrial statistics. It is the exact point where data meets decision-making. Learn anytime, anywhere, and prepare yourself to lead in tomorrow's industries.